Welcome back. So today we're going to be working on volume of prisms. So this is the first of our three-dimensional shapes. So you should have a foldable that looks like this. You're just going to open that up. And we should have some images like this. We have a few different prisms here. All right, so looking at our solids, we are going to start with our volume formula. So up above our pictures, we're going to put capital V equals capital B times H. Okay, so now when we're working with this, our capital V is volume. Capital B represents area of base. Because now since we're working with three-dimensional solids, our base isn't a length anymore. Now it's actually a two-dimensional shape that we're working with. And then finally, we have the little h, which still represents our height as it has in the past. Okay, so let's take a look at our first shape here. So we have a couple different types of prisms. So the first prism that we have, this is called a right prism. And the reason why this first one is called a right prism is because the angle that's formed here with the sides and our bases, or the edges and our bases, is perpendicular. So we have right angles there. So that's considered a right prism. We also have this one over here that's called an oblique prism. So an oblique prism is where now you'll notice it's slanted. So it's not perpendicular. This edge is not perpendicular to our bases anymore. Now it's at an angle. So whenever we have a tilted shape, is the way I kind of like to think of it, we call those an oblique. Then the last one that we have over here, so this one is a triangular prism. So we have a rectangular prism that's a right prism, we have a rectangular that's an oblique, and then we have a triangular. You can really have any base for your prisms. I just wanted to give you some different examples so that you could see what's going on with those. So like I said, we're going to start with our right prism. So looking at that one, sorry, I didn't mean to cut off our formula there. We're going to start with our formula, V equals capital B times H. So now when we're looking at our shape, this down here is our base. So if we want to find the area of the base, for this one, it is a rectangle. So we're going to take length times width, and then we're going to take that times the height of the whole prism. So in our example, our length and width, we have 5 and 2. Those are the dimensions of the base. So we're going to take 5 times 2 is our base, times our height of our prism here is 6. Now please keep in mind, since this is a rectangular prism, we could actually turn this on any of the faces and we would have a new base. So for this particular one, order really doesn't matter here since we're just multiplying everything together. Okay, but I wanted to make sure to go through how we get these different pieces with you. All right, so next we're going to take 5 times 2, which is 10, times our 6, and we end up with 60. So volume equals 60, and our label is going to be centimeters cubed. And it's cubed this time because we're talking about how many little cubes, 1 centimeter cubes, would fit inside of that prism. Okay? All right, so the next one that we're going to do is the oblique prism. Okay, and that's that one. Our oblique prism. Now our formula is still going to be exactly the same. The only difference is where we find the height. You notice on this one, the height is the length of this edge. The height over here, it's no longer the length of that edge because that edge is slanted. Now we have to find the height that's perpendicular to our base. Remember, height is always perpendicular to our base. Okay, so volume equals capital B times H. So volume, our base is still a rectangle, so we're going to go length times width times our height. In this case, our base is 8 by 4. We got the 4 from up here. So 8 by 4. And the height is 10 because the height, remember, has to be perpendicular to our base. So we're going to take 8 times 4, which is 32, times our 10, which is 320. And then this is going to be inches cubed. Okay, we are going to go ahead and do one more here with our triangular prism. With our triangular prism, we're going to go ahead and put some measurements in here. We're going to have 3 inches, 5 inches, and let's go with 8 inches. Okay, so we have some measurements there. And I'm going to go ahead and mark that this is a right triangle in here. So now if we look at that triangle, our formula is going to be the same here. V equals capital B times H. But this time for our capital B, we're going to use the area for a triangle, which is 1/2 little b times H. And remember, this is the area of the base. So this is different than this H out here. Okay? So that's very important that you know that those are different numbers. So now let's look at this shape. They gave us this side length, but we also need this one. Well, if we look at our triangle, it's a right triangle, and we know one of them is a 3. We know our hypotenuse is a 5. Okay, so I just took my shape and I brought it down here. This is the base. So if we know that this piece is 3 and this is 5, that means this one has to be 4. That is a Pythagorean triple. You could have also used Pythagorean theorem. 3 squared plus, we'll say little b there. Actually, let's not do that. Let's call this a. A squared equals 5 squared. And we would have got 9 plus a squared equals 25. And we still would have ended up coming up with 4. 25 minus 9 gives us 16, which the square root of that is our 4. So to get the area of our base, we're going to take 1/2, 3 times 4, okay, 1/2 of our 2 legs that are perpendicular to each other times the height of the whole prism. So let's come back up here. The height of the whole prism was 8. So we're going to mark that as 8. So now we're going to take 3 times 4, which is 12, 1/2 of 12, which is 6, and 6 times 8 is 48. So now we have 48 inches cubed. Volume equals 48 inches cubed. Okay, all right, well that is all that I have for you today for prisms. We'll be working with another solid here shortly. Have a great day.